Alrighty, let's talk about determinants today. Okay, we know what a matrix is now. Not every matrix has a determinant. For a matrix to have a determinant, it must be square. Okay, if it's not a square matrix, no determinant exists. So again, square matrices are 2 by 2, 3 by 3. They have the same rows, same columns. Same number of rows, same number of columns. Alright, so now let me just put this over here. And let's start off with a second order determinant. Again, don't forget the order is how many rows and columns it has. Okay, so a fifth order would be a 5 by 5, as an example. All right, well, let's give ourselves a matrix A here. And let's call matrix A, B, C, D. I don't like that. I'm going to make that a little thicker. Hold on. And change it to purple. All right, so if that's the matrix A, and the question is asking us, what is the determinant of A? You'll see it asked that way, but the notation I want you to see, be familiar with also is this one, A, B, C, D. Okay. Notice the difference between these two. Okay, this is brackets. Brackets indicate a matrix. This looks like absolute value signs. This one is the determinant. Okay, don't get confused with that. You can also see it represented like this. All right, now how do we figure it out? Well, if this is our matrix, I am going to take the product of these and subtract the product of these. So that would give me A times D minus B times C. Okay. Most common mistake I see each year is people confuse, they do BC minus AD. Well, here's how you remember. You're always starting with the first row, first column. Okay, remember how we, first row, first column, so always start with that number and then take this product minus that product. Okay. All right, let's do an example. Okay, let's change it to green. What do we got here? So I'm asking you to find this. 7, 3. Okay, now notice this is not a matrix, this is a determinant. I'm asking you for the determinant, and you can tell by the fact that it looks like absolute value signs, not brackets. Well, we start with this number right here, the first row, first column, and we're going to have 5 times 3 minus negative 2 times 7. And the determinant doesn't give us another matrix. It gives us an actual value. We'll talk about what that value means at a late, probably tomorrow, but right now let's just figure out how do we solve these things. That's going to give us a 15, that's a minus 14, which is plus, which gives us a value of 29. So the determinant of this matrix is 29. Matrices with a determinant fall under two different categories. They're either singular or they are not singular, and it's very easy to determine. Really just this, if your determinant is 0, it's singular. If it's not 0, it's non-singular. So was our last example singular or non-singular? Our determinant for that last one equaled the number 29. 29 does not equal 0, therefore it was non-singular. Tomorrow when we talk about what we do with these, we'll also discuss the difference between these two. Okay, but right now you may be asked for homework to just identify them as singular or non-singular. Now for the fun stuff. A third order determinant, a 3 by 3. Well, let's see what we're going to do here. I have, and I wanted to use this. Oh. We are going to find the value of this third order determinant. I have a 2, 1, negative 3, 0, 8, 7, 4, 6, 5. Okay, well, let's first set it up the way we had it before. So if I take the first row, that's going to give me a 2, a 1, and a negative 3. And then what we do is we cross off the row and column with 2. So if I got rid of this row and this column, we'd be left with this 2 by 2 right here. which is an 8, 7, 6, 5. All right, now the 1. Well, if I take the row with 1 and the column with 1, I'm left with these 2 and these 2. So let's write those in. That would give us a 0, 7, and a 4, 5. For the negative 3, well, now I'll just write through it. If we cross off the row and the column with negative 3, it's going to leave us with this 2 by 2. 0, 8, 4, 6. And then what we do is we alternate signs. It's positive whatever, it's negative whatever, it's positive whatever. And this is exactly what I mean, positive whatever. Since this is a negative 3, we're adding a negative 3, so ultimately this is going to just turn back into negative 3. And also, because I'm just subtracting a negative 1, I have a minus 1 here, it just stays negative 1. But for argument's sake, if this were, let me just change the color real quick. If that value was a negative 1, not a positive 1, I would be minusing the minus 1, which would then turn it positive. Okay, so just keep that straight. And again, put a star next to it. If it still doesn't make sense, I'll explain it in class tomorrow. Okay? Now let's get rid of that. Here we go. I have 2 times. Well, how do we figure out a 2 by 2? It's going to be the product of this minus the product of this, which gives us 40 minus 42. Minus 1 times. I get 0 times 5 is 0, minus 4 times 7 is 28. Plus 3 times this one, which is 0, minus this one, which is 32. And now let's just figure out what this thing equals. I have 2 times a negative 2, which is negative 4. I have negative 1 times negative 28, which is a positive 28. And then we have a 3 times a negative 32, which is a negative 96. And what does that give us? Well, if you add it up, that's going to equal 120. So the determinant is 120. This is a non-singular matrix. All right, now for the identity matrix for multiplication. Well, let me just give you these. Give these first. The identity matrix for multiplication. Only square matrices have an identity matrix. Okay, if it's not square, there is no identity. What it is it's what you multiply a matrix by to get that matrix back. Before I do matrices, it's the same idea with regular multiplication. What's the identity for multiplication? What do you multiply a number by to get that same number back? Forget about matrix, just talk about numbers. Well, 7 times what will give me that number back? Right? 2/3 times what will give me that number back? Okay? So 1 is the identity for multiplication for numbers. The same thing with matrices. If I take 2 matrices called A and B, what do I multiply matrix A by to get matrix A back? Okay. In this case, I called it B, so B would be the identity matrix. Same logic. Okay, so let's... Oh, I'll just put it up here, and we'll do an example here. Okay. They're denoted with a big I for identity. Let me change the color here. So I, and it has a little subscript. If it's I2, that is the identity for a 2 by 2 matrix. It's what you multiply a 2 by 2 matrix by to get the matrix back. If you see this, I3, that means it's the identity for a 3 by 3 matrix. What do you multiply a 3 by 3 matrix by to get that matrix back? Okay, and I think you can follow the pattern. Here they are. For a 2 by 2, which is a second order matrix, 1, 0, 0, 1. For a 3 by 3 matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. For a 4 by 4 matrix, 1, 0, 0, 0. You could just follow the pattern here. I think you're seeing it, and if not, I'll tell you in a second. Okay. they're all zeros except for the diagonal going from the top to the top left to the bottom right. Okay. So in here everything's zeros but that. In here everything is zeros but that. In here everything is zeros but that. Okay. So just keep following the same pattern for any identity matrix. Let's do a little example on this stuff now. Okay, I'll leave that over there. Say I gave you 2, 3, 4, 5. And I'm going to multiply it by its identity matrix. 1, 0, 0, 1. All right, well, how do we multiply? Well, I'm going to take the first row and the first column, and I'm going to get 2 times, so here our answer matrix. Oh, here, first off, remember it's a 2 by 2, a 2 by 2. The middle numbers are the same, so we can multiply it. And our resulting matrix is going to be the outside numbers, which is also a 2 by 2. Okay. So for the first row and the first column, I take these numbers, and we're going to get 2 times 1 is 2, plus 3 times 0. For the next one, okay, I have, so here, let me change the color here. So now for this one, this is the first row and the second column, so we take the first row and the second column, and we do the same thing. That's going to give us 2 times 0 plus 3 times 1. Okay. Down here, we're going to take this row and this column for here, and then over here, this is the second row, second column. We will then take the second row and the second column and repeat the process. So that's going to be a 4 times 1 plus a 5 times 0. And then a 4 times a 0 plus a 5 times a 1. And our final answer, after we simplify, is 2, 3, 4, 5. Ta-da! All right, well, hopefully that made sense to you, and you did take notes on that. Okay, again, if you have any questions, bring them into class tomorrow. We'll go over them. And then we are going to work on this textbook homework right here. We're going to be doing determinants. Oh, look at that. Looks like we have a quiz coming up. Be mindful of that. I tell you what sections it's on. Okay, have a great day.